All right, everybody, we are moving on to number 3 in your 3.6 homework assignment. So this is a hefty problem, I will be honest. Last week, while driving, you dropped some change from your pocket, 3 quarters, 2 nickels, and 3 pennies. So 8 total coins that you had in your pocket. Then later you needed the coin for a parking meter, so you reach down, you grab out 3 coins, you can't tell which ones are which, and so we want to find the probability of all these things happening. All right, and it did ask you to make a tree diagram. This tree diagram is freaking epic. I made it here, and you can see I've already kind of been marking things up as I try to figure this out before doing this video. But basically what's happening is the first grab could either be quarter, nickel, or a penny. And so there's a 3 out of 8 chance of it being a quarter because there's 3 quarters out of 8 total coins. There's a 2 out of 8 chance of it being a nickel because there's 2 out of 8 nickels. And 3 are pennies out of 8 total coins, so 3 out of 8 chance of it being a penny. And then from there, I want you to build the rest of the tree diagram, check out all the probabilities, and then pause this video, do that yourself. Okay, hopefully you have tried this on your own. I'm going to let you copy down what I have here. So pause the video again, make sure that these match. Okay, here's the rest of them. Move here. I just want to make sure you see them all. Okay. Here's the rest of them if you need them. Okay, so we should have a tree diagram to help us out. All right, A and B are kind of related. All right, this A says the probability that the first is a quarter and the next 2 are not quarters. So if it says and, this is a union. Okay, so we want the probability of event A and event B. Oh, and, sorry, that's 4. It's an and statement. So A and B. All right, that is the product rule. Okay, but I'm going to pause there for a second. B is the probability that the last 2 are not quarters, right? Similar to this. If the first 2 was a quarter, similar to this. So this is an and statement. This is an if statement. This is the given. If is another way for given. So this is asking for the probability of A given B. Okay, so to help us out with this, I'm going to call B, right, the given that the first coin is a quarter. Okay, A is going to be event that the next 2 are not quarters. All right, so I'm going to start with the probability on B because A given B is needed for this. Our product rule says we want the probability then of A given B times the probability of B. That's our product rule. Okay, so I'm going to start by finding A given B down here because we need that for up here. So A given B, we're going to use the tree diagram, and I've already got all of those. That's when you multiply across a tree diagram. So we want to know the probability of the first coin being a quarter and the next 2 not being a quarter. All right, so I'm going to really mark these up. First one's a quarter. Next 2 are not. So we cannot use anything on this branch because the second coin is a quarter. So nothing out here that we need. All right, so we'll go back. First coin I draw is a quarter. Next one could be a nickel. That works, right? But then I cannot draw another quarter because the condition is the next 2 are not quarters. So can't do this one. We could do this one, right? Go quarter, nickel, nickel. We could go quarter, nickel, penny. All right, we could go quarter, penny, nickel. We could go quarter, penny, penny. All right, so there we go. So we can add all these up because we are adding vertical lines. So this would be, I've got 3 that are 0. And again, I got these calculations from multiplying across. So I did 3/8 times 3/7 times, 2/6 to get this number. And then 3/8 times 3/7 times another 2/6 to get this number, right? So this is where these calculations came from. So I've got, for this one, 3 of the 0.054. So this plus this plus this is the same thing as 3 times 0.54 plus 0.018. All right, so I can do this in a calculator. 3 times 0.054 plus 0.18. So, oh wait, sorry, 0.018. Whoopsies. So 0.162 plus 0.018, whoopsies, is 0.18. Okay, so this is 0.18, so about 18% probability. All right, we're going to use that in this problem now. So this is the probability we just found. So this is 0.18 right here times the probability of B. And B was the event that the first is a quarter. So the first one being a quarter had a 3/8 probability. This is right at my start, 3 out of 8. So I'm going to multiply here, 3 out of 8. Okay, so I've got times 3 divided by 8 is about 7%. So I'm going to just put, whoops, 0.0675, which is about 7%. Okay, cool. Then we want the probability of exactly one coin being a quarter. All right, so I'm going to go through at my tree diagram and look at how many combinations I have with only one quarter. Okay, so I've got all these combinations. I've got 18 possible combinations. That's our fundamental principle of counting, right? 18 choices, because that's 3 times 2 times 1, 3/4, 2 nickels, 3 pennies. 3 times 2 times, sorry, what am I saying? 3 times 2 times 3. I'll write that out here. 3/4 times 2 nickels times 3. 3/4 times 2 nickels times 3 pennies is, that'd be 6 times 3, which is 18. So we have 18 total possibilities of coins that I could grab. That's, yeah, available, which is all showed here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Wait, oh my gosh, I've heard too many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7. 27. Where does this come from? Oh, because I'm picking three coins, I guess. Well, anyway, okay, so our sample set is 27 possible grabs. So that's, I'm gonna write that here. Sample set is 27 because we got 27 possible grabs. There we go. How many of these grabs only have one quarter? Let's count. Okay, so we could have the first one be a quarter, but then that means that none of the others can be quarters. Okay, and we already circled those. 1, 2, 3, 4. So those are the possibilities there. 4 there. Then I could have a nickel, quarter, nickel. That's 1/4. I could have nickel, quarter, penny. I could have nickel, nickel, quarter. I could have nickel, penny, quarter. All of those have only 1/4 in them. All right. Then I could go down here. I could have a penny first and then a quarter. So then these could not, no other quarters there if it's the second one. All right. I could have penny, nickel, quarter. And I could have penny, penny, quarter. Okay. All right, so we would add up all these probabilities that I have boxed for the probability of 1/4. So 0.18 right there. How many of these? Oh, 0.018. Oh my gosh, be careful. So I've got 1, 2, 3, 3 of those. I'm going to just multiply that by 3 instead of adding that 3 times. It's going to be the same thing. Plus 1, 2, 3, 4, 5, 6, 7, 8, 9. times 0.054. So we have a 54% chance, it looks like, that we will have at least one, or have exactly 1/4, I'm sorry, exactly one. So we added all those up, we have a 54% chance that that one is a quarter. Okay, next. The second is not a quarter, given that the first is a quarter. So we are going to check out these, the givens. I'll do this in a different color here. So given that the first is a quarter, bam, that the second one is not a quarter. So we have nickel or penny. So we could have probability of 3/8 times 2/7. So that'd be quarter to nickel. Plus, though, we have another option, the probability of 3/8 to 3/7, quarter, and then penny. So this, here we go. All right. 0.267, right? I'm rounding up. This is about 27%. Okay, then that the second coin is a quarter. So similar, second coin is a quarter. I gotta circle these branches. So it doesn't say anything about the first quarter. So it could be here. So it could be this probability to get to here. So this times this. Plus it could be this one. This times this. Plus it could be this one. Second coin is a quarter. So we will add all these up. I could have first one's a quarter, 3/8, and the second one's a quarter would be 2/7. Plus, I could have picked a nickel first, so that'd be 2/8 times 3/7. Or I could have gone 3/8 times 3/7. Okay, so let's add all those up. There we go. Okay, 3/8 times 3/7. All right, 0.375, which is about 38%. Okay, then the last coin is a quarter if the first two were quarters. So we're going to pick all three quarters. The last coin is a quarter, the first ones are quarters. So we've got here, oh gosh, my tree diagram is right here. All right, so I went quarter, quarter, quarter. It's right here, 0.018. That'd be about 2%. And the last coin is a quarter. So I've got my last coin being a quarter here, last coin being a quarter here, 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 and here. All right, so I'm just adding all those up because we're moving vertically. So I've got 0.018 plus 0.036, this guy, plus 0.0, oops, I got the plus sign, plus 0.054 plus 0.036 for that one. Oh, we on this one. Plus 0.018 plus 0.054 plus 0.054 plus 0.054 plus 0.054. All right, so I get about 38% again. That? Amazing. So 38%, same as the second one being a quarter. So there we go. That's interesting. So let's see. I want to make sure I didn't miss any. 1, 2, 3, 4, 5. Plus 2 of those. Plus yeah. Okay, so yeah, so that is the coin problem. Pretty massive, pretty gnarly. We're gonna do it again, kind of, with some card probabilities.